Okay. Can you hear me?
Yep.
Yes.
Okay, great. I keep forgetting. I need to write down how the votes were beforehand for people online because I think they cannot see the poll.
It was 7-1-3-3.
7, 1, 3, 3. Okay, that's kind of about what I thought. So that's the first time around. Let me create a new poll and we'll see how persuasive you guys were. Okay, go ahead and vote again. Need 2 more votes. Haley. Oh, look at this. 7, 0, 6, 1. Haley, did you have a question?
No, that was an accident. Sorry.
Okay, no, that's okay. I just don't want to ignore you. If you guys raise your hand, you can just talk. Okay, that way I don't have to, like, if you raise your hand, go ahead and if I'm asking for responses, go ahead and talk. So I see a big change here. A lot of people stayed with 1, but of the other 3, they seem to largely have sort of coalesced around option 3. And I know some people told me that they were kind of between 1 and 3 already. So maybe some of you, went from 1 to 3 and others moved. But this is interesting. Let's talk about number 2 first, because nobody is now picking number 2. So somebody tell me what's wrong with number 2. Haley.
Didn't we say that like if it's speeding up, the curve would be like flipped the other way, like going up this way instead? So this would mean it was slowing down.
Like this?
Yeah.
Well, no, not exactly. So a curve like this would be slowing down on the first half and speeding up on the second half.
Well, I mean like down from the origin, like that, but up and down. I could be wrong. It's fine.
So speeding up means the slope is getting bigger. So from the origin, speeding up might look something like that if you were starting at rest. Okay. And so how does that relate to number 2? If this, I would agree, what I just drew here would be an example of speeding up.
Well, I just like ruled that one out because like line B didn't look like that. So in my like perception, I was like, well, it looks like line B is slowing down.
Okay, so line B is not speeding up. So they can't both speed up. And what about train A? Is it speeding up?
Yes. Right? Quickly, or I don't know.
So, okay, speeding up means slope increases. And it's easy to kind of confuse speeding up from moving up. So A is moving forward, but at a constant rate because the slope is constant. So technically, A is not speeding up or slowing down. So hopefully that you're having the right idea. Those guys, neither one of them looks like what speeding up looks like. Neither of them is kind of curving upward or curving away from a 0 slope. What about option 3? We have one person who's still voting option 3, but a few people changed their mind about that. So if you change your mind about, sorry, did I say option 3? Option 4 is what I'm talking about. If you change your mind about option 4, what made you change your mind? I know I heard people talking about why they were not picking option 4. So tell us why you're not picking option 4 now. Isabel.
Okay, so kind of with option 2, obviously they don't have the same accelerations because it has an acceleration of 0 because it's like a straight line, and then B has a negative acceleration, so they obviously aren't the same.
Okay, so that's a great point. Train A has 0 acceleration because it's neither happy nor sad. Train B is clearly sad, so it has a negative acceleration, and negative and 0 cannot be the same. So yeah, I agree with that. So we can definitely, we can definitely cross out number 4 and number 2. But if you look, we're very sort of evenly poised between number 1 and number 3. So I'd like to have an instant runoff election. Maybe we can have somebody advocate for option 1 and someone else can advocate for option 3, and then we'll vote again. Can someone tell me why option 1 is right? Okay, how about someone for option 3? Tell me why option 3 is right. Chandler.
So originally I picked option 1, but if we were going to draw a line for the slope for B at TB, the slope's not going to match that of A, therefore they wouldn't have the same velocity at point TB. So 3 would be correct because somewhere along the curve of B, they would have the same slope.
So where would that, like somewhere in this area?
Yeah, somewhere right around there, close to it.
So you're saying they're parallel sort of at this point. Okay, but there's a good argument for option 1. Someone tell me a good argument for option 1. So I like what you said, Chandler, but I'd like to hear from an option 1 person because I heard some good arguments for option 1 when I was in rooms. Nobody wants to say something in favor of option 1. Okay, let's just revote. Maybe that, maybe some of you have changed your mind. Let's see here. One more person needs to vote. Okay, there we go. And voila, it is the final tally is, for people at home, 2 to 12 in favor of option 3, which only had 3 votes to begin with, I'd like to point out. Option 3 is correct. Let me talk about option 1 though, because if you picked option 1, you're thinking the right way. It's a little bit about fine print about the language. It says at time TB, both trains have the same velocity. And people who pick option 1 are probably thinking in terms of there being a delta X and a delta T, and they both travel the same distance in the same time, and so their velocities are the same. And this would be absolutely true if the question is asking us about average velocity. And the fine print is that it says at time TB. So when it says at time TB, that's really implying instantaneous velocity. So that's the only thing that really invalidates number 1. If it just said they have the same velocity during interval TB, then 1 would be correct and 3 would also be correct, because what does 3 say? It says they both have the same velocity sometime before time TB. Now, Chandler's argument that the velocities are different at time TB is really good because the slopes are clearly different, and they're also different at the beginning. But the problem here is train B starts out faster than train A at the beginning, and it's slower at the end. And you can't go from being faster than something to being slower than it without crossing through its speed. So for example, let's say train A is going 20 miles per hour, and train B starts off at 30 miles per hour and is later going 10 miles per hour. You can't get from 30 miles per hour to 10 miles per hour without crossing through 20 miles per hour sometime. And even if we can't exactly pinpoint it, it has to be the case. The train B is faster at the beginning than train A. It's slower at the end, and so sometime in the middle it must be the same. So good job. This is a perfect example of how these should work. It's there to help us. It's not to see who's smart or who gets it. It's more that nobody has the whole picture probably at the beginning, and by talking to each other, if you're right and you explain it to people, you're going to understand your point of view better. If you have faulty thinking and someone convinces you when you're struggling not to let them convince you, then eventually you'll come to a better understanding. So these exercises are really helpful, and you will see on occasion on the contests conceptual problems like this. And so you really need to build a conceptual understanding, and that's what this does. So just the more we do it, the easier it will become to just vote however you feel, and to stick to your guns if you think an answer is right, because oftentimes the right answer only has a couple of votes at the beginning, and by the end it's nearly unanimous. Any questions about this problem or question? Okay, so let's go back to our master equations. I'm going to just grab, I lost my toolbar. Where's my, okay, I cannot grab the master equation, so I'll just rewrite them. Okay, let's do problem still from the same book. Problem 3.10. And it says, a box slides down an incline with uniform acceleration. If we want to translate that as a math sentence, there's no math translation for that. That basically just says we can use the master equations because the acceleration is constant. Second sentence, so we can ignore the first English sentence almost entirely. The second sentence says it starts from rest and attains a speed of 2.7 meters per second in 3 seconds. I'd like you all to try to translate. There's 3 math sentences in that English sentence. I'd like you just on your own, on your paper, go ahead and try to translate those 3 math sentences, and I'll write them down in a minute. So the starting from rest says V initial equals 0, attains a speed of 2.7 meters per second. We'll call that V final. In a time in 3 seconds, so T equals 3 seconds. Hopefully you guys all had something like that. Then we have our questions. Find A, the acceleration. So question A says A equals question mark. Let me use a capital A here because just so it's not confusing a little bit between the A's. So this is question A, says find the acceleration. And question B, this is the tricky part. Use a capital B. The distance moved in the first 6 seconds. So can anyone translate part B, question B for me? Well, finding the distance traveled is the easy part. Delta x equals question mark. But how do I interpret this in 6 seconds? In the first 6 seconds. How do I write that as the math sentence? Katerina?
Would you times it by 2?
Well, you're yes, in a sense, but what I'm trying to do is just figure out a math statement that says that information, as opposed to how to get that information.
Your T final would be 6 because it's like the first 6 seconds. So then from your initial
Okay.
to 6.
All right, but do I have a T final in my master equations?
Technically, because T equals TF.
Okay, but then this first one would have been also T final, which is a nice proof that 3 equals 6. We should publish this. So you get my point. There's a problem here. There's a problem here in that we want to say T equals 3. Maybe I should just do undos. And we also want to say T equals 6 seconds. But we clearly cannot say both of those things. So what's happening here is this is our first problem where it's not perfectly, elementary. And if we try to solve this without a structure, we probably have a 50% chance of getting it right and a 50% chance of making a mistake. So what happens in part B is it's asking us about a question about a different time interval from part A. And so what we have to do is we have to be kind of careful and go through all of these things and maybe think of them as V initial for part A, V final for part A, T for part A, and acceleration for part A. And then when we go to part B, we can put B's just to keep our symbols straight. And some of the information from part A will still be relevant for part B and some will not. So part B, what is part B? Part B is from 0 seconds to 6 seconds. If we make a graph of this thing, let's make a little graph. It starts at rest, which means the graph initially is flat. And then after 3 seconds, the speed is some positive number. And then it says constant acceleration. So however curvy it is, it must stay just as curvy kind of the whole time. So here's 3 seconds, and here is 6 seconds. And part A is talking only about this, while part B talks about the whole thing. So having this graph can help us organize our thinking. Now, we want to know delta x for part B, so that would be this distance here. And we know the time. This, we could call that TB, and this is TA. But what else do we know about part B? Do we know the initial velocity for part B? The initial velocity for part A is 0. Is the initial velocity for part B also 0? What?
So we're assuming that part B is starting at like 0 seconds and then or is it starting at 3 and then going?
That is an awesome question. The answer is we can do it however we want. So when I looked at this problem, I thought of it this way, that TB would be the entire 6 seconds, but totally valid if we decide that this is TA and this is TB. Okay, if we do that second thing, we would say, part B says delta X A plus delta X B equals question mark. That would be the question, because here is, delta X A is just the first part, and then delta XB is the second part. So if we're kind of conceiving of part A and part B as the first 3 seconds and then the second 3 seconds, then it would look like that. TB, we would say, is also 3 seconds because we're going from 3 to 6. And then we can analyze everything with this in mind. Or the way I was thinking of it is we're going to start at 0 for both time intervals. So TA is 3 and TB is 6. It's just important that you be clear in what you mean when and drawing a graph can help you kind of clarify that. Now, I'm going to stick with this first approach, but I would encourage you to try again later to test yourself and use the second approach and see, there's a different strategy, but it still will work. So going back to my question, is V initial for B, is that still 0? Well, it would be in this first point of view, but in the second point of view, it would actually be whatever is the final speed for part A. So you can work it either way. I'm going to work it as V initial for B equals 0. What about V final for part B? Will it still be 2.7 meters per second? Yeah, it won't be, because, use a different color. This is the V final for part A, and this is the final for part B. So they would be different. So I can't count on that. And what else? Let's see. We have V initial, V final. We can't count on. The T for B, we know. The acceleration, for part B, would it be the same as the acceleration from part A? So they're both happy. It's happy part A and part B. We have to probably go back to the English and look a little bit. And here's where that first sentence comes in. It says it slides down an incline with a uniform acceleration. So uniform means constant, and that means A, B, and AA are in fact the same. Okay, so that's what we need to translate. This is a much harder problem to translate. And like I said, we might get lucky without going through this process and still get it right, but we may also easily make a mistake. It could be very easy to make a mistake if we don't go through this translation process. So now that we've done it, now that we've translated, let's see if we can solve it. So for part A, I want to find the acceleration. And I look at both equations have acceleration. Okay, they both have it. So in principle, we can pick either one, but one may be a little easier than the other. So I would tend to say, look at what else we know. We know V initial and V final and T. And if I look at these two equations, the second equation has all of the stuff that we know, but the first equation requires that we know delta X, which we don't know. So we want to pick equation 2. V final equals V initial plus AT. And then we're going to check what we know. Do we know V final? Yes. Do we know V initial? Yes, and it's 0. A is what we're looking for, and do we know T? Yes, we do. And probably I should put A's on everything, just to remove any doubt. So we can now do algebra and solve for A sub A. Since the velocity initial just disappeared, I have V final A equals AA times TA, and it's real easy. To get the A by itself, I just divide by TA. So V final A over TA equals acceleration A. And we can now plug in our numbers. And again, your tendency as a student may be plug in numbers first and then solve, but I really want to encourage you to solve first and then plug in numbers. So that's 2.7 over 3. That's going to be 0.9. And I didn't write in any units, but I know what the units for acceleration should be. They're always going to be the same. They should be meters per second squared. So there's my acceleration. Any questions about solving for part A? Okay, then we can solve for part B now. We only have one equation with delta x for part B. Okay, we have one equation only. So I'll pick that one. Delta x b equals v initial b t b plus 1/2 ab t b squared. And then we check, do we know everything we need to know? Do we know the initial for B? And again, I don't want to look back at the English and try to figure this out. It's a bad losing strategy. I want to look at my math sentences. It's very easy. Okay, VIB equals 0. I know it. I can cancel it because it's 0. Then I look, do I know AB? I do. Do I know TB? I do. Do I know 1/2? Yes. So can we solve it? Yes. So delta x b is equal to 1/2 times 0.9 times 6 squared. So let me see what that is. Looks like 16.2. Wait a second. I don't think that's right. So, is it 20? I'm getting 20. You got 20?
No, it's 16.2.
It's 16.2?
Yeah.
Yeah, that's what I got.
Okay. So, and what would the units be for that?
Meters.
Meters. So I don't need to go in and put meters per second squared and put seconds here and square them and then cancel them. You don't need to do that either unless you're nervous that you made a mistake. And then if you forgot to square the seconds, you know, if you forgot to write t squared, you just wrote t, the units would help you find that mistake. Okay, so this is already a harder question. What makes it harder? It's harder because it's got two parts. It's got two parts. It's not just find velocity and then find delta x. It's some stuff happens in one time interval and then something happens in a different time interval. And when our time intervals are not the same, we have to kind of reinterpret the English for each time interval and make sure we're clear what we're talking about. And it's not unique. There's not one way to do it. So like I said, I encourage you to, if you want to test yourself, you know the answers now, try this second method, thinking of TA and TB as each 3-second intervals and see what you can come up with. And you should get the same answers. Okay? Any questions about any part of this? Now, I'm going to tell you, I am not surprised if some of you are looking at this going, oh my God, look at this. It looks nuts, all these symbols. And this is in part why you need to work with symbols first and plug in numbers at the end, just to increase your comfort level. Okay, it's about comfort level. When you're looking at all these symbols, it makes you uncomfortable. It's like it's like math already, but you're taking the test, and the math book is written in Russian, Cyrillic characters, and you're looking at it and you feel like you kind of know what to do, except for you, Elena. You're going, I feel like I know what to do, and yet it just feels alien to me. And that's because in math class, we always work with X and numbers, and in physics, it's all symbols. And we need to get good with that. So if you find yourself in a problem not being able to deal with all the symbols, try to solve it by plugging in numbers, but then go back and re-solve it with the symbols, because the strategy will be exactly the same. So I want to look at one more problem before we go, and we may not be able to finish this problem, but the problem is going to illustrate a direction that we want to take going forward. So this is problem 3.13. And it says, an auto's velocity increases uniformly from 6 meters per second to 20 meters per second while covering 70 meters. So in translation, it's V initial equals 6 meters per second. V final equals 20 meters per second. It's not showing my meters. And while covering 70 meters, that delta x equals 70 meters. Find the acceleration and the time. So A equals question mark, T equals question mark. Now let me put our master equations up again. Delta x equals V initial T plus 1/2 AT squared. V final equals V initial plus AT. Okay, and now we want to find the acceleration. First of all, how many equations have acceleration in them? This is an easy one. It's 2. Okay, 2. Okay, how many of the equations have time in them? Just hold up fingers. 2. Okay, good. So this means, we can use either equation for either one in terms of, it's not like we don't have a choice. So which equation should we use for the acceleration? Let's try the first equation. Delta x equals V initial T plus 1/2 AT squared. If we want to use this equation, we would say, do we know delta x? Yes, we do. Do we know V initial? Yes, we do. Do we know time? No. Do we know 1/2? Yes. And we want to find the acceleration. So can we find the acceleration? Can we find it with the information that is provided? The answer is no, we can't, because we don't know the time. So we have two choices when we get in this situation. One choice is, and this is usually what we will want to do, is to find t. We're going to try to go somewhere else and find the time. The other option is try another equation that had acceleration. So let's try a second equation. If we have V final equals V initial plus acceleration time, and we check, do we know V final? Yes, we do. Do we know V initial? Yes. And because I have this translation, it's a tremendous improvement not to have to go back into the English to figure these things out. I want to find A. Do I know the T? No, I don't. So I either have to find T or pick another equation. But guess what? We don't have another equation. So this is what we kind of have to do. We have to solve one of these equations for T and plug it into the other equation. This is a classic two equations with two unknowns situation that you see in math class. But it's hard to recognize it because in math class it looks like a plus, or x plus y equals 2 and x minus y equals, 3. And then we solve it either by substitution or elimination. And if it looked like this, you guys can all do it. But when it looks like this, it looks, it's very hard. Okay, well, we can do that, and it's a hard process. It is hard, especially on, the third day of class, which is why I'm offering it to you as an extra credit assignment. Okay, it will appear later today in Blackboard under extra credit. And you'll have until class time tomorrow to complete it. And if we do that process, if we solve one of these equations for T, keep in mind we don't have numbers for everything. So this is a situation where we can't plug in numbers. If we solve one of them for T and substitute it into the other equation, so in effect we're eliminating T, and rearrange, doing some algebra, we can get what will become our third master equation. V final squared equals V initial squared plus 2a times delta x. Now these three will be our three master equations. The third one technically isn't really a master equation, but it's so much work to solve a problem like this without that equation that it's worth doing the hard work once to derive this equation with no numbers so that then for the rest of our lives we can use it. This is how humans are on top of the evolutionary chain, because we make tools, and that's exactly what this is. A hammer is a tool. Hammer, you can make a hammer, and it takes a lot of work to make a hammer, but once you have it, now you can drive lots of nails. If you try to drive nails without a hammer, it's less work to drive one nail without a hammer just by finding a rock. But if you have to drive a lot of nails, it's worth it to make a hammer. So this is exactly like that. And the whole physics class will proceed. We'll be generating new equations from old ones so that we can use them and make our lives easier by doing hard work one time to make all the other times easy. So how are you going to solve this? Well, I would recommend solving the second equation here for T, because the first equation, solving for T, is going to be much harder. You have a T and a T squared. And plug into the first equation here and here. And then simplify. So if we've done all that hard work, okay, this is the extra credit. If we've done that hard work, we are able to use this third equation, and it's very easy to solve for A in the third equation because it doesn't have time. That's what was causing us so much trouble before. So we just rearrange this third equation. Oh, it should be plus. So when I want to solve for something, I first move anything that's not attached to it to the other side. So I'm going to move the V initial to the other side by subtracting. We get V final squared minus V initial squared equals 2a delta x. So that's a strategy in algebra class. Move the things that are not attached to the other side first by addition or subtraction. And then anything that is attached, we move it by multiplication or division. So we're going to take now the delta x and the 2, and we're going to move them to the other side by division. So we have v final squared minus v initial squared over 2 delta x equals a. And now I plug in. Again, as a student, you want to plug in first, okay? But I'm trying to convince you that if you do that, it's like going to the gym and working out, and you get the 2 biggest guys in the gym to spot you. Normally you can only bench, 120 pounds, but with the 2 biggest guys, you can bench 300. And so you go to the gym every day and you bench 300 and you feel super awesome because these guys are lifting for you all the time, but you never get any stronger. And you can't figure out why you're not stronger. So you have to work with the symbols to get stronger. And this is one way to practice that. So V final is 20. So 20 squared minus V initial, which is 6 squared over 2 times 70. So let's get a number for that. I get 2.6, and the unit should be meters per second squared. Let me know if you got the same thing. Anybody get that? Anybody get something different? I got it twice, so I think that's right. And once we find the acceleration, now we can go back to one of these 2 first equations and solve for time. The second equation looks a little easier. So let's try it. V final equals V initial plus AT, subtracting the V final from both sides, V initial from both sides because it's not attached to the T is the first step. And then we divide both sides by A. So T equals V final minus V initial over A. That is 20 minus 6 over 2.6. And that's about 5.4 seconds. Did anyone now get the same numbers that I got for, acceleration, for example? Okay, great. Now you may be wondering about how many digits to keep, especially if you had chemistry, because your chemistry teacher is like a guardian of the digits, and they force you to have a certain number of digits. And I don't really care how many digits you keep. So you could call it 5.38 or 5.4. I'm not super picky about that. The only time I would take off points on your digits being different is if maybe you were supposed to find the difference between 2 things and you rounded them too much, so you just get 0, but you should really have like 0.02 or something. But I would say 99.5% of the time, I don't care how many digits you keep. So it's probably, not worth worrying about at this time. Any questions about this problem? Can you see how much nicer it is using the third equation? If we have the third equation, it's way better. So it's worth doing this extra credit, doing the work involved in the extra credit. From my perspective, it's worth it to create a new equation, which then helps us for the rest of the semester. From your perspective, this is a little bit challenging, this extra credit, but it's, give it a shot. It's worth it. Do it on paper, and then just take a pic of the paper, and you can upload the pic where the assignment is. So look under course content, there is going to be an extra credit assignment, and when you click to do the assignment, it's going to ask you to upload a picture. So just upload a pic of your page or pages. Any questions about what you need to do for the extra credit? Is it clear? So, okay, let me just say it again once more. You're going to solve the second equation for t. It's going to look like t equals, you know, some stuff. And then you're going to just take that stuff and replace both of these t's. The second one, you will then have to square it. Okay, so when you square it, it's going to be like foiling something. It's going to be a big, ugly thing. Then you're going to start canceling things and simplifying, rearranging until you get to the third master equation. Okay, so it's really worth it because it's the type of working with symbols that you need to be able to do within the next, I'd say, 3 weeks or so. If you can't accomplish this extra credit today, that's okay. It's not gonna, you know, you will get there. But if you can do it today, you're off to a really good start. Okay, so that's it for today. If you have questions, you can stick around and I will wait to see if you have questions. But otherwise, you know, please try that Respondus practice test. Make sure your technology works there. And, you know, try this extra credit before class tomorrow, and I'll see you then. Thank you.